Hi everyone, thanks for joining us for today's webinar where we will be talking about site-specific weed control technology. I'm Shannon Barrett, Communications Officer here at WeedSmart, and today I'm joined by WeedSmart's Southern Extension Agronomist, Greg Condon, and we also have Dave Tuppen from Gold Acres with us. Dave is a precision farming expert who's working on the Green and Green product development at Gold Acres. Dave and Greg will both be able to answer your questions at the end of this webinar, so please make sure that you send your questions in during the presentation via the Q&A box on the toolbar at the bottom of your screens. Before I hand over to Greg to get us started, I'd just like to acknowledge the support of the WeedSmart stakeholders, which you can now see on your screen. All of the companies above the line are our financial contributors, and everybody below the line are our in-kind stakeholders. So I'd like to say a massive thank you to all of these companies for their valuable contribution to WeedSmart. I'll now hand over to Greg to get us started.
So this presentation actually is a summary from the WeedSmart AGM that was held in Melbourne recently, where we presented some information to our stakeholders. So we want to make them aware of, I guess, what was happening in terms of trends in broadacre weed control, not only in terms of green on green, but also the other innovations that are not green on green, but are still operating from a site-specific level. So it comes as the outcome from a workshop held in Wagga early this year, which was hosted by Michael Walsh from Sydney University and organised with Guy Coleman for GEDC, looking at a scoping study into how green on green could have a fit in the Australian broadacre system. So we're a long way off that becoming a reality. So what we presented to a lot of those delegates who came from around the world at that green on green workshop is some of the current weed control tactics that are in use and some that are emerging and have a really good fit, whereas others are some way off and still in the process of development. So we'll get into it. Thanks for coming. So first of all, just what's currently happening. I'll just take a step back and talk about Big Six. So that's an important aspect of IWM, so integrated weed management in Australian systems. So WeedSmart have come up with the Big Six, which I'm sure many of you are aware of, but some of the site-specific aspects of weed control do fit quite neatly into the Big Six. And particularly non-chemical practices. So a lot of these are really complementing the herbicides we have out there and protecting either existing chemistry or new chemistry, of which there's quite a range of new products coming onto the market. We actually have a webinar in a couple of weeks to sort of follow up on some of that new chemistry. And then in the end, I'll talk on the workshop that was hosted in Wagga to a degree, but also broadly what's happening not only here in Australia, but also around the world. So in terms of green on green, what it actually is and how it could work in the paddock. So the WeedSmart Big Six, this is a key part of all our messaging. So there's so many integrated weed management messages out there. So what we aim to do, for those of you who are aware of the WeedSmart process, is bring all that messaging back into one platform, and that's why we've termed it the Big Six. Starting with diverse rotation. So it just means weed control tactics that you have that complement each other at different phases of a crop sequence. So diverse rotations obviously allow diversity of herbicide use, diversity of crop types, double knock. So in the eastern states, particularly this year, we've got this fantastic opportunity to protect glyphosate with the double knock practice. So we can sort of come back and target hard to kill weeds like ryegrass and sow thistle, mix and rotate. So that's, I guess, a key part of any herbicide program is the ability to mix herbicide groups and modes of action, but also rotate them between the rotations we have and different crop types. So that's really important with all the chemistry that is available. And historically, integrated weed management was probably based around rotation of herbicides, but we really expanded it to take it to another couple of modes or another couple of practices in the Big Six. Crop competition, that's a favourite of mine. So using the crop itself to compete with weeds and help reduce seed set. Stopping seed set is another key one. So in recent years where we've been influenced by dry seasons, in some areas, haymaking's been really important, but for people who are growing pulses, crop topping is really important, and also with canola. So if any weeds do get through, there's an option to control them late in the season. And then last of all is harvest weed seed control, which has historically been probably the flagship of weed management with non-chemical tactics from WeedSmart. But we've got all these other tools that we can complement it with. So that's the big six, and I just want to sort of put some of the practices we'll talk about in the presentation into perspective around that integrated weed management platform. So non-chemical is now mainstream, so we do spend a lot of time talking about herbicides, but it's really that ability to bring in some of the tactics. And you see the photograph there of unfortunately a fairly drought-affected canola crop being cut for hay, but in the same vein, it was a pretty powerful tool to clean up some of the resistant ryegrass in that same paddock. So these big six tactics have become standard operation, which is it's quite unique globally. So we can talk about integrated weed management as in non-chemical tools that are being used in our no-till system. So we're not compromising no-till, we're adapting and using these alternative tactics. Hay is proving effective and very profitable, particularly in the southern region and WA as well. Crop competition is something of a quiet achiever, but it's gaining more and more traction as people sort of realise the value of taking away that space, with hybrid canola, for example, or even competitive cultivars such as barley. So you've got different crop types that are particularly competitive against grass weeds at certain stages of the growth stage. So a certain stage of the growth cycle, I should say. So using crop competition. But then the big one is harvest weed seed control. So this is something that Australia leads the world globally in terms of a practice of effectively not spreading those weed seeds back out over a stubble once we've harvested the crop, actually doing something with them, either destroying them or leaving them to rot or burning them. So there's a range of tools used there. So harvest weed seed control objectives for growers. There's some Twitter surveys that WeedSmart have done. So at least by 2021, growers are really committing to either chaff lining on the left, chaff decks in the centre, or some chaff carts, which are still in use. And then the big one is the mill technology. We've got the HSD there, the Harrington Seed Destructor, and also the Seed Terminator, but there's a number of other mills that are coming onto the market. So there's aiming to be 25% of people using a mill, which is a big jump from where it was even 2 years ago. So we're seeing at least 50% of the entire crop area will have some form of harvest weed seed control, which is a completely non-chemical weed control tactic. So there's 4 mills available, and this is another form of site-specific weed control. So we're managing weeds in terms of capturing them year in year in different crop types and then destroying them. So these 4 mills that are available with the WELG on the left, HSD in the middle, the top, and then the new Redicop MAV on the top right. So and the Seed Terminator. So we're able to set these systems up at harvest to capture the weed seeds and destroy them physically. So we're reducing that total seed bank. But I guess taking a step backwards, you sort of look at the technology that's being employed on existing operations in terms of applications. So really about the timing of weed control and hitting targets, and it's not an easy process. It's just a photograph I took from one of our clients this year with a 6,000 litre 36 metre boom. So they've got a 3-tier system, so they can run three different sets of nozzles. They've got height control. You can see that little black structure there in the middle of that green frame. It's all operating on 2 centimetre RTK. So again, it's site specific. So they're able to constantly target weeds under a guidance system with some pretty elaborate technology. And this is not even taking it to the next level. This is just standard broadacre weed control. And then all the logistics that go around that as well. So another example of a grower from the Darling Downs, Peter Baish, aiming to make the process quicker in terms of filling. So this is another aspect of it that growers do put a lot of effort into, and the systems need to be robust around the logistics. So that's sort of another example about it's not just having the technology to control the weeds, it's actually the system around actually getting the timing right and making sure we fit in with inversion limitations and control restrictions that might happen, but still do a great job. Uh, in terms of the ultimate, well, we're talking about green on green, but the ultimate site specific that we have set the current benchmark, and that is green on brown. So in fallow scenarios, so you've got the weeded camera spray there on the left, and their new blue camera in the middle there of the weedits, and then the new Trimble Weed C2. So this has already got a really high level of rigour in terms of fallow spraying. So you can take in green weeds out of a fallow. Growers have adopted this, particularly in the northern region and some in WA and dry areas, large-scale operators across the Mallee of Victoria and South Australia with great success. So effectively taking a fallow application from 100% on average down to between 10 and 15%. So it's come along in the last 3 years in particular with growers we work with here locally, but there's a really strong network that have developed around some of the settings and conditions that make these camera sprays work well. So you're effectively taking a sensor which reflects from the ground, picks up an image of a weed, and then activates a solenoid to spray that weed. So this is the current standard, a really high benchmark. But it still is a bit of a balance between the agronomy, economics, and logistics. So I was just talking to an advisor who works in the area of southern Queensland, northern New South Wales. So they've got a lot of these machines operating in their area already, but it's a big investment. So you've got to be really conscious of you're going to get value from that investment, particularly for medium and smaller farmers. And I guess the challenge in certain years is knowing when to sort of use the broadacre boom or when to pull out the camera spray. So it has come a long way. It's still a juggling act, and sometimes the settings can be a bit challenging, but largely that work is advancing, and growers in the field and advisors are sort of sorting it out with the individual companies. So it's still something that there's a lot of adoption to happen in Australian systems. So we'll see more and more of it in time. And the next step on from that is autonomous. So the activity of using the camera sprays largely in fallow is a fairly monotonous job. A fair bit of paper, scissors, rock goes on with some of the operations of who's going to sit on these machines and go back and forth. It's pretty mind-numbing stuff because you're not really filling up. So if you look at the Swarm Farm team, they've taken to another level, building 12-metre automated weeded-based cameras on their units, so they can operate by themselves without having to have an operator sit on them. So that's coming to market again, another Australian innovation, which is quite remarkable. And there's a photograph there of Andrew Bates from Central Queensland, who was a developer of the Swarm Farm platform. So that again will help complement the weeded and other camera spray technology. So that's something that's in progress, and more and more farmers can hopefully look at some sort of development work or trial work to see how it might fit for them. Probably the last one in terms of the camera spray technology with the fallow aspect is a project that the University of WA and Sydney Uni have worked together on, and it's now been commercialised by Precision Agronomics in WA, is using weeded sensors on a cultivator bar to chip out fallow weeds. So largely in the northern system. So this project's been in play for a few years now. They've done quite a lot of trials where this the chipper comes in and digs out those larger perennial weeds that might have survived, or annual weeds that have proven hard to kill with the knockdown technology. So it's a physical cultural tool that can chip out those remaining either resistant or tolerant weeds with a non-chemical tool. So it's really effective. 6-metre bar there in the illustration at 10 k's an hour is what the trial work's been done at. So that's something we hopefully might see more of as a commercial partner does development. So that's one that's come out of Australian systems as well. CropStalker is a company that, or a platform that Southern Precision in southern South Australia, so in the southeast area of South Australia, they've come up with a platform where shielded sprayers, which have been around for a long time, have been used in wide row crops, but they've developed a machine now that actually goes down to to a really narrow row spacing, so a 10-inch or 250mm row spacing, and can move between historically used in pulse crop types, but also now in cereals. So it's quite an exciting development that, again, they do have a camera mounted on there that steers the shields rather than the shields just moving between the rows by themselves. And they've just extended that to put a Weed Seeker 2 camera sprayer between the shields. So that's really exciting technology that's been developed locally and potentially will have greater fit. So that Green Seeker will go into trials this June, talking to Grant Yates from Crop Stalker. So that's something has, particularly in crops like pulses, chickpeas, lentils, whatnot, are really hard to take out large broadleaf weeds like south thistle or prickly lettuce late in the season, and we run into issues with IMI residues and whatnot and crop damage. So these Crop Stalker or shielded sprays has a really good fit for this type of application. And again, it's all on a site-specific technology basis. So the platform is managed by the guidance, and the weed control tactic is activated on that site-specific basis. Another farmer adoption into farmer innovation, I should say, is a process called weed lining. So we look at chaff X, which is a former harvest weed seed control. So Warwick and Dye Holding from southern New South Wales have taken that to another level, where the chaff X were depositing, and this is, I'll put this into context, a paddock that had a really high pressure. So the whole farm doesn't look like this. It was just an area after the wet year in 2016 that had high ryegrass pressure carried over. So they then set up their little crop coop. They were able to able to spray only 12% with selective herbicides on that in that faba bean crop to target that ryegrass, and then again at maturity with crop topping. And then the chaff X came through. It's on a 12-metre CTF system, so any ryegrass that was a survivor was collected and put back on those same chaff X again. So it's a very hostile environment. So whilst it looks pretty thick with that level of ryegrass in one area, Michael Walsh's work has shown there are a lot of I guess decay does happen to a degree, but there's just seed loss because they just don't have that seed soil contact. So you go back to that paddock now in 2020, and there would be less than 10% of that seed number there, which was really high to start with. But it's a form of site-specific weed control that is really quite easily adopted from a chaff lining harvest weed seed control platform. So onto the green on green, which I guess is what most people have probably logged in today to hear about. As I said, Michael Walsh and his team from Sydney University, Guy Coleman included, organised a workshop in Wagga earlier this year, and luckily prior to the whole COVID-19 event situation, whatever you want to call it. So delegates from around the world came to discuss what they were doing in their space and also what was happening in Australia. We took them out on farm for a couple of visits. So I guess the key thing they were looking at, so some of their discussions were looking at green on green, or particularly site specific, so where they can use the technology, particularly for low weed densities. An exciting thing is this ability to reduce inputs, like we've seen with the green on brown, so the camera spray in fallow situations by 40 to 90%. So massive dollar savings for growers in this technology. So the opportunities are to move away from herbicides. So we've got some alternative technologies that are out there, which people like Guy Coleman and his team at Sydney University at Narrabri have been working on with laser. There's also steam, cultivation, and even microwave, because you're only applying it to a small area in a site-specific basis. So you're not having to basically, for example, use a steam or a microwave across a large area. It's targeted, and the weeds are known, and the tactic is employed. We can use new herbicides. So there's certainly expensive modes of action that sit on the shelf with some of these companies that haven't seen them brought into play because of cost. But in an Australian market particularly, we're very cost sensitive. That's some of the products we use, and also helps with resistant management, targeting resistant populations with alternative chemistry, but also protecting the chemistry we have by reducing the application of products that could be more at risk from resistant profile. reducing crop damage, and this is a bit of a given. Like as an advisor and growers, we just see the damage that a standard herbicide can do, herbicide mix for that matter, to any crop growing during the season. So if we have the ability to go in and on a green on green perspective, particularly, and just take out the weeds and leave the rest of the crop alone, it certainly has an impact on that crop damage, and largely reducing the total volume of pesticide that's being applied to our grain crops, particularly late season applications where some of the grain residues with MRLs are an area that's coming with a lot of attention from our end users. So that's something that has some big potential. I guess at one point that was made, it's critical to have a high level of in-crop recognition. So if you know the conditions that we work in Australia, it's often rough terrain and difficult seasonal aspects with cold weather and temperature and whatnot. So it must be close to the target if we're going to be doing it green on green. And platforms like AutoWeed and Bilberry and even Swarm Farm have already moved a fair way down the pathway of helping with this in-crop recognition. So there's companies already, as we'll talk about, building these platforms that we can mount some of this stuff on. So what is machine learning? I guess I'll be honest, a lot of people out there explain this a lot better than me. So just as my take on what was presented at the workshop. So it's basically the study of mathematical models that sort of are put into computers to help set up a specific task, and then building on what they call learned patterns. So it's a subset of artificial intelligence, AI. And there's some really good papers, actually. GRDC in the ground cover last year, Andrew Story put together a whole lot of great information on green and some of the basis of the technology behind it. So the AI, particularly deep learning, is a way of working on images to recognise different objects. So they can use computer vision to sort of look at the weeds in crops or weeds on bare soil, and then start to make differentiation between those weeds. So it's deep learning is inspired by the human brain, which uses, I guess they term it deep neural networks architecture. So it's all interconnected, but it's this reliance on learning patterns is a key feature of it. So as I said, there's people that explain that a lot better than what I can, but that's just my take on how machine learning is having a role in agriculture and its step into weed control. So just an example I thought I'd pull up for you. Here's a crop of barley. I took this photograph last year prior to maturity. So that barley is actually ripe, but the wild oats are pretty happy setting seed. So the process of deep learning and building an algorithm. So I guess they first of all define the objectives of the algorithm. So we've got wild oats and barley here. I've said 90%, greater than 90% accuracy, but from the green on brown stuff, so in fallow, you'd probably want it to be 98, 99% accuracy. So that's the standard that needs to be higher than what I've set. They look at gathering the data, so they take pictures in the paddock, and those pictures need to be taken from a whole range of different scenarios. So in the morning, at night, cloudy days, sunny days, for example. And then the big job is sorting and labelling the data. So really working out what are the wild oats and what is the barley. And that's quite an expensive and laborious process. But again, with the computing power becoming available now, they can streamline that somewhat. And then they go back and try and train the algorithm. So they run the model thousands of times and really start to build this pattern, so the algorithm or the model can start to learn what the pattern is and differentiate between the wild oats and the barley. And then they test the algorithm in the paddock many times. And at this stage, a lot of this green on green stuff has been fraught with a lot of frustration, but it's only early days. But the testing is a big part of it. And then, as they all said, it's repeated. So it goes through the process, gathering the data, sorting it, training it, testing it, but then that's repeated again. So they just repeat the process until the algorithm is, I guess, a bit more dependent and can have some repeatability. So green on green, Michael Walsh again and his team from the workshop. So they're looking at if you see in that application there, photograph from a crop in season, to be able to come in and put a site-specific application of you might taking broadleaf weeds out of that wheat crop, for example. So how can that work, and what are the key timings that might sort of fit? So looking at recognition of weeds across large-scale cropping operations, all the challenges that might go with that. So you've got two key timings that Michael talked about, which were really important from a practical perspective. So early post-emergence, so you've got a large area, short time period, generally an open canopy. So the weeds are fairly small, so the timing is critical. And it could actually be a combination of blanket and spot spraying. So if you're doing grass weeds in a broadleaf crop like canola or pulses, you more often than not might be doing a blanket application to target those grasses. But if it's a broadleaf in a cereal crop, then it could be a common just spot spraying, for example. The second timing that Michael talked about, and I think this is probably one of the most exciting ones, is the late post-emergence. So you've got a large area, you generally got a long time period. So you're aiming to stop seed set. You think back to the big six, where we're talking about stopping seed set, particularly from potentially resistant populations. So timing is less critical. Generally got a closed canopy, and some of the work that Salar Sakara from Sydney University is doing, they're sort of looking at a shrouded camera with a light source with the weed shredders they've been doing. But for us, an exciting part of this process would be, say, a chickpea crop or a pulse crop where we have late season broadleaf weeds that come through. South is all prickly lettuce, which are generally quite difficult to control or unable to be controlled. So other than shielded spraying, if we could have a green-on-green application at that time of year, it would be fantastic. But near enough is not good enough. So during the workshop, there was a really good debate around why not just target what's not a crop. So we've got a wheat crop, for example, and anything else around that, particularly broadleaf weeds, why not just spray that? So the scientists and the I guess weed biologists in the group that have been working in the space all debated this at length, and it was really interesting. Should we just look at the target what's not a crop, or use a sophisticated system? So one that's an all-encompassing database that sorts by plant type. So you've got weeds versus crop. You've got different species, like your brassica weeds, for example. You've got the size of the weed, your plant structure, even the soil colour. So that it apparently gives the ability to train a lot better with machine learning using the higher level of specificity. So if you measure everything first and then get it down to an individual level, that is generally more accurate than just having that basic outlook of saying, well, this is the weed, this is the crop, so just leave the crop and target everything else. That's not as practical. That they'll get more value and more longer term accuracy with the green-on-green process by training the model to have that specificity. So you measure everything and get it down to that individual level. So a couple of examples of what's happening around Australia. Guy Coleman, who was at the workshop, is fantastic sharing his work. He's been looking at some real-time detection of ryegrass in wheat, amongst other things, doing lasers as well. So the workshop also was aiming to see if we get an open source data set for the Australian conditions. So he has some really clever research happening in the lab and in the field. So you can actually sort of follow Guy's work on Twitter. He's always very good at sharing how they're making this site-specific green-on-green stuff work in his area. Matt Hewitt is another one from South Australia. So he's a robotics engineer looking at some real-time detection of weeds in lentils, particularly with broadleaf weeds, which is a bit what I was talking about before. We can just target the generally small numbers of weeds that are generally pretty challenging in a pulse crop. So there's two sort of researchers that are really active and doing some clever work. At the next level, there's some big investment from overseas companies. So Guillaume Jourdain presented a fantastic paper at the 2019 GDC updates, and I would encourage you to go through and listen to Guillaume's presentation from the WeedSmart conference in Horsham last year, and the paper from the GDC updates, where he goes through the work they've been doing both in Western Australia and in Moree, New South Wales, on the green-on-green work with the Bilberry platform, which is originally came from France and now has set up the head office in Australia. And Goldacres, we have Dave with us today, but they also are working in with Bilberry to look at a factory-fitted weed sensing technology to be able to have their boom platform carry the carry the technology to do green on green. So there's a lot happening in this space. There's some really good resources out there for people who are interested in finding out more. And I would encourage you to look at that paper from Guillaume from last year. One group that has sort of been operating in Queensland, so Alex Olson and the team from James Cook University at Townsville have developed a platform called the Auto Weed, so designed for woody weeds in tropical pastures. And I guess the one thing about Alex's team is really wanted something lower cost and retrofit. So whilst originally designed for pasture, or tropical pasture scenarios, they are looking now to pull that retrofitted option into some broadacre work. So again, using machine learning to detect the visible images, of colour, shape and texture. And he's looking at upwards of 90% image accuracy. At this stage, they're limited to 10 kilometres per hour, either with green on brown or green on green. And there's some trial work happening in northern New South Wales this year with some partners that Alex and his team have helped develop. So it's that camera is a lot of low cost components that can be fitted to a standard boom in time. So that's one to follow. One camera covers 1 metre, so they're looking at 3 solenoids per camera, and it's around $3,000 a unit. So significantly less cost than some of the other hardware platforms that are out there. So it's one to follow if you're interested, or particularly based in the north. Tom Wolfe, I don't know if anyone is aware of this, put a thread on Twitter last year, which was fantastic. So he went to Agritechnica, which is a farm machinery exhibition in Germany every year. And he went through and looked at all the individual stands that were sort of, talking about the green on green stuff at that demonstration last year, or that exhibition last year. So there's some very big companies playing a part in developing the technology. So Amazon was one. There's another couple of slides. John Deere with the Blue River. So that's a company who was bought out by John Deere with a hydraulic nozzle system for horticulture initially, then potentially take it out to a row crop. And then Tom had some fantastic commentary in and around the whole green on green or optical site-specific sort of weed control stuff. So it's it just sort of seems that Australia is leading the world in the space, but there's a lot of interest from some big players at a corporate level as well. So anyway, I guess in summary, that I've got a few questions to go back through, but there's some emerging farming systems. So we need to be able to cope with variable seasons and keep our weed control cost effective. So in-field spraying is certainly becoming more complex with tight windows and drift and whatnot, as we talked about earlier. But this ability to bring some of the site-specific tools, such as the shielded spraying on narrow rows for pulses and cereals, is probably an initial step for many growers if they're looking to take it to another level and diversify their weed control application tactics. The green on brown is already there with growers achieving weed seeker and weedits upwards of 99% accuracy. So that's in a fallow scenario only. So that's probably the practice that has the most value at this stage. But I guess the last one is the green on green. So there's a long way to go. We probably still haven't even fully nutted out the green on brown side of things with that complex of economics and agronomy and logistics. So the green on green is probably even further away in that regard, but still there's a lot of clever people, particularly here in Australia, working on the space, because those cost savings that we talk about and that crop damage effect is really significant. So if we can start to build in those platforms for weed control in Australia, I think it's a pretty exciting space. So thank you.
Awesome. Thanks, Greg. That was a really great overview. We also are joined by Dave Tappen from Gold Acres, who works on green and green development with Gold Acres. Did you have anything to add, Dave?
Probably just touch on a couple of things on where Gold Acres are at, because that's potentially a question on a few people's lips out there. So we've joined forces with the guys from Bilberry and we did that back late last year, back in 2019, sorry. And a couple of main points that we really wanted to retain with our current system is keeping the simplicity of our sprays that we've got today, be that the current 3TS or the 3-tier system, and our rapid fire, rapid flow system, just that whole spray control structure that we've had for quite a few years now, that is proven to be quite reliable and simple to maintain and everything. So being able to get the Bilberry system to talk with our current system has been quite a challenge, and it's taken a fair bit of development, 6 months of time probably, I suppose you'd say, to the point where it was only 2 weeks ago that we actually started doing some in-field testing of that with our rapid fire system, with fantastic results. We were a little bit concerned of the ability of that air-operated system to be able to keep up with the timing of spraying weeds at speeds between 15 and 20 kilometres, but early signs of that are proving to be quite effective and very reliable and accurate in doing that. The other thing we wanted to keep in mind too was the ability to use one machine that could do your standard all day, every day blanket spraying, and pretty much with the flick of a switch go out spot spraying, not necessarily pull up into the shed and change over the sprayer and hook up another sprayer and then go back out and do that. So with the direction we're going in, we believe we're probably 80% there in achieving both of those goals. And there's just a bit more work to do in refining that and getting that up onto a bigger machine, which we're just about to step into in the next couple of weeks, on setting it up on a 36 metre boom and actually getting out in the field and doing some proper field trials. Probably just to elaborate a little bit, green on brown, yep, that's happening. We can do that. Using the camera system is still physically looking for weeds, so it's using that AI deep learning that we've already spoken about a bit, to actually look for weeds, and that's proving quite reliable. The next step, of course, is going to the green on green. That becomes a lot more complicated because it actually does have to identify what is crop, whether that be canola, wheat, barley, chickpeas, whatever else it might be. And if you can imagine that the system has to know and be able to see and identify each individual crop at every individual growth stage through any period of time of the day or night, it has to be able to look at that and say, yes, that's wheat and that's a weed, and be able to differentiate between them through all of those different parameters. So there is a lot more work in getting green on green to work accurately and consistently, and that's sort of our next 6 months, hopefully, realistically, who knows, project that we've got to sort of get our teeth into and get that bedded down. So yeah, that's probably it for me at the moment.
Awesome. Thanks, Dave. We've had a couple of questions come through. You may have just answered a little bit of this question from Ben White. Of the steps to get to green on green happening on a commercial level in Australia, crops and weeds, what do you see as the biggest hurdle? This is to Greg and Dave, I guess.
From the workshop.
You go, Greg.
Sorry, you go, Dave. Yeah, from the workshop participants, I guess it's the complexity, Ben, of the weeds we have, but also the environmental conditions. So we took them out on farm, visited a few growers during the workshop, and just to make some of the scientists working in the space aware of how challenging it is to do weed control in Australia compared to where like other platforms in Europe, for example, are being operated. So it's a bit more challenging from a environmental perspective. So that's probably the big one. But just that cost recovery and reliability, the two big aspects. So if you can spend a lot of money on some of the technologies, just getting it back to a cost cost-effective entry point for Australian growers. As you know, they're very price sensitive, and for rightly so.
Awesome. Dave, do you have anything to add to that?
No, I think that pretty much sums it up. I probably just to expand a bit more, that the complexity of the identification of a weed or a crop. Basically, what they have to do is take a photo of whatever the plant is you're trying to identify, and literally they sit down and trace around on a computer, trace around the outside of the edge of that plant, and that has to be very, very accurate, and use that as the basis of the starting point. But they also need to have that plant, again, as I said before, through all its different growth stages, from being, suffering from lack of moisture, or in broad daylight, in shadow, all those sorts of things. So that one plant may have 20 odd different photos taken of it during its lifespan. So you can imagine doing that across a 100-hectare paddock. There is a lot of work into it, and that's why the timing of this is a little bit unknown at this stage. There are some trial algorithms out there at the moment to try out, but unfortunately the weed that they're using for the trial is not the common one that we see around here. But we will definitely be trialling some of that stuff before the end of the year.
Yeah, great. Thanks, Dave. We've had another comment and question from Paul McIntosh, our Northern Extension agronomist. Paul said green on green is a fantastic development for cost saving and crop safety in the daytime, I assume, is the starting point. How big a step is it to get nighttime green on green?
That is a reality. It can be done. The only thing we need to do is provide light so that the camera can see it. Pretty much if you can see the weed, the camera can see the weed or the crop. It's not quite as simple as just whack a little light bar underneath every camera. It's a specific type of light that we need to use. We have done some trials with our test system and found that different types of light react differently to reflection and all that sort of stuff. No different to taking a photo with your digital camera or something like that. So yes, it will be a reality, and it's something else that we are working heavily on to develop and get sorted out.
Great, thanks, Dave. And we've had another one asking about chemical rates. Can higher rates of chemical be used on spot weeds, or does the label stop this?
Glenn, yeah, it's a good question. So New Farm have pursued this already. So with some of the green on brown stuff, so that they've got registration for quite a number of their products. It is a grey area with the APVMA, so it would be something that would need to be developed in time. But from I guess the work that someone like New Farm's already done, some of the other companies that were present at the workshop, for example, were generally pretty positive about pursuing it further. So the labels do stop it at this point, particularly for other herbicide manufacturers, but they seem to think that would something they could pursue.
Great, thanks, Greg. Well, I think that's about it. I just wanted to mention that we have done a couple of podcast interviews with Alex Olsen and Guillaume, and we actually did a podcast on Agritechnica as well. So we'll link all of those podcasts and resources in the link on our website for this webinar, if anyone's interested in listening to those. Dave and Greg, do you have anything else to add before we wrap up?
No, thanks for the opportunity. I really want to follow up on this. There's some great papers out there from Andrew Story, who did the summary for ground cover. I think it was 12 months ago, but also Guillaume's paper from the GDC updates from 2019 and his video of the presentation from Horsham last year. But the paper is really valuable and something I refer back to a lot. So it's a good resource.
Yeah, great. We can put that link up on the website as well. So we just have had a quick another question come through. Realistically, how long to use in less widespread crops, e.g. chickpeas or mung beans?
Well, I think Yeah, it's the weed identification is the key. So when you're Dave, so getting the actual crop type's probably not that specific. It's just identifying. So if there's herbicides already registered, for example, in chickpeas or mung beans, then it's actually getting the camera to to identify those weeds and create the learning to activate the control agent. So it's probably chickpeas are probably closer than what mung beans would be. It's the pulses are really important from all the companies that talked about this stuff. So they're a high priority. Mung beans I'm not sure of, but it's you'll probably see more development for that late season application, as I mentioned in the presentation.
Great, thanks, Greg. All right, well, we'll wrap it up there. I just wanted to let everyone know that we are having another webinar in 2 weeks' time with Peter Newman talking about the cost of harvest weed seed control. So same time, same place in 2 weeks' time. All right, thanks everyone for joining.
Thanks for joining.
Thanks, guys.